Promises are another popular approach in JavaScript to deal with asynchronous events and are an alternative to using callbacks. Note that promises are built into JavaScript and don't require a separate library like RxJS as observables do. So a promise is an object representing the eventual completion or failure of an asynchronous operation. So what's the difference between a promise and an observable? So an observable can be used for many events. An observable is a stream of events over a period of time. Promises are used for a single event and can't be used after that. A promise has a different structure and use case to observables. So a promise is treated as a value. For example, a function can return a value as a promise, and the actual value of that promise will materialize at a later point in time, remembering that a promise is being used to manage an asynchronous event. To have a function execute asynchronously, simply have it return a promise. In this example, we are using the XML HTTP request object, which is an object used to make HTTP requests. The XML HTTP request object is from an old API, and it would be good to be able to update it to use promises. Network requests by their nature are asynchronous, which means that the return value, or the value from the URL that we request, won't be available immediately. The HTTP response object provides callback functions to respond to a loaded page or a failure. A promise constructor takes one argument, a callback. This callback has two arguments, either resolve or reject. So we do some functionality in the callback, and if it worked and the value becomes available, we call resolve. If it fails or the value is not available, we call reject. So we will piggyback on the HTTP request objects on load and on error callbacks to trigger the resolve and reject functions of the promise. Using the new function OpenURL allows us to make HTTP requests without having to type all the XML HTTP request all of the time. When we call the OpenURL function passing a URL, we provide callbacks for response or error to the promise using the then function. The first callback is the resolve function and the second callback is the reject function. Sometimes only the resolve function is provided, and sometimes it may be necessary to check only for an error state with no resolve. Then the value of resolve would be set as null. Recently, JavaScript has added a fetch function which is simpler to use than the HTTP request object, and it is based on promises. This is how you can use fetch. So fetch is going to return a promise, and the promise is then what the response becomes. So using the .then syntax and passing a function that will respond as the positive return response, as in the promise has been resolved, will then allow us to console log out some data of that response. Note that fetch returns a HTTP response object and not the raw data. So within the response object is a property of body which contains all of the data of the body of the web page. Let's have a look at another fetch example. So in this one, the page is requested and we wait for it to complete. When the page has been loaded, this is the first then section, the data will be parsed as a JSON file and we wait for that process to complete. When the parsing of the JSON file is complete, so that we're now into the second then section, we will log the contents of the file to the console. In this way, we can chain a series of promises together so that the value of the first asynchronous request can be used in subsequent asynchronous requests. As mentioned, asynchronous programming can be difficult to implement because it is non-sequential in nature. Chaining promises allows us to write code that appears to be sequential, but each step executes asynchronously and waits for the previous step to complete without holding up the rest of the code. JavaScript has recently added a new async await syntax that allows us to write promise-based code as if it were synchronous. An async function can use await to call other functions which return promises and wait until the promise is resolved. In this code, we have created two functions that return promises. One will resolve with the text slow after a 2-second wait, and the other will resolve with the text fast after a 1-second wait. We can then use these functions in an asynchronous function. We can see that the code is greatly simplified and reads more like synchronous code. The await statement pauses execution until the item resolves so that the next await can then be resolved. The entire function returns a promise and is asynchronous, and as such, the main UI is not blocked. In the previous example, the following lines of slow equals await resolve after 2 seconds and fast equals await resolve after 1 second is equivalent to chaining the promises. So using a resolve after 2 seconds dot then, we do something, and our return value for that is then another promise, which then resolves as something at the end. So just to recap, so await can only be used in functions that are declared as async. Await can only be used to call functions which return a promise. And await will execute the then function on the returned promise. And await will cause the call to then to wait and not proceed until it has been resolved. Async functions can only return promises. In the example below, the return boolean will be wrapped in a promise. As mentioned, observables are different to promises, primarily in that they handle multiple events, whereas promises only execute once. However, what if we wanted to convert a promise to an observable? RxJS has a powerful from function which can be used to convert many different things into observables. It is primarily used for iterable objects, i.e. arrays, where each array element will be passed to the function of the observer in sequence. However, it can also be used to convert a promise to an observable. In this example, we convert the promise returned from the fetch function into an observable.